section 10.5 is all about volume and surface area. Up until this point, we've been dealing with shapes in 2 dimensions, flat shapes that only have a length and a width. When referring to doing different calculations about the outside and inside of those 2-dimensional shapes, we were finding perimeter and area. Now we're going to kick it up a notch and talk about 3D shapes, 3-dimensional shapes, which is, of course, a little bit more useful because we live in a 3D world. We have a height as well, so there's going to be length, width, and height involved in these shapes. So now, if we're filling up the inside, it's no longer called area. Filling up the inside of 3-dimensional shapes is called volume. The units for volume will always be cubed. Surface area of a 3D shape is like finding the perimeter of a 2D shape because it's the outside. So surface area is the outside of a 3D shape. Just picture whenever it asks you for surface area, like you're gonna plan to wrap those shapes up in wrapping paper. The units for surface area are always squared. So with area and surface area, units are squared, whereas with volume, the units are cubed. Perimeter, units stay the same. I've attempted, sadly, with my lack of artistic ability, to draw these 3D shapes. But honestly, all you have to do on the homework is first be able to correctly identify the shape. Then, yet again, you just look up the formula and plug into the formula. This will also be provided on the handout that I'm uploading into your course that you are welcome to print out and use on the test. That way you don't have to memorize any of these formulas for test day. Just need to know, of course, how to use them. So the first 3D shape that I've tried to draw is a sphere. And a sphere would be like a marble. It's completely circular. The volume is 4/3 times the number pi times the radius r to the 3rd power. Because there is a circular shape involved, that's why we see the number pi. The radius is the circle there that's in the inside. A rectangular solid is up next. The volume, you just simply multiply the length times the width times the height. L times W times H. By the way, a cube where all sides are equal is a type of rectangular solid. So you could use these formulas, these rectangular solid formulas, on a cube as well. The surface area formula that I have in teeny tiny writing, it's a lot longer. I promise it's not as bad as it looks. SA for surface area equals 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. That way you're calculating the area of all 6 sides by the end of it. Cone is next, just like an ice cream cone. You got a circular bottom and a pointed top. The volume is 1/3 times the number pi times the radius r squared times the height. Because of the circle shape on the bottom is why we see the number pi. Pyramid is different than a cone because it's a box or like a rectangle-ish shape, sometimes square shape on the bottom. And a pointed top, the volume is 1/3 times the base b times the height h. A right circular cylinder, or they might just call it circular cylinder in the homework. The volume, because you have 2 circle shapes on either side, is pi times radius r squared times height h. It does kind of look like a soda can. It is a right circular cylinder. The surface area formula, 2 pi r squared plus 2 times pi times radius r times h. Let's look at an example. In the example, it says to find the volume and surface area of the following figures. So looking at A, I've tried to draw that soda can shape where you have circles on both sides. So remember, that's a right circular cylinder. The volume formula for a right circular cylinder is pi r squared h. So let's go ahead and plug into that formula to find the volume. So bring over the pi. The radius r, well, that's from the center of one of the circle sides to the end of a circle right here. I'm circling it. I know it's teeny tiny writing, but it's supposed to say 5 centimeters. So 5 is the radius r. It needs to be squared according to the formula, times the height of that soda can right here. It's 7 centimeters. So pi times, I'm going to do the exponent before I multiply. 5 squared gives me 25. Bring down the 7. And let's pretend that the answer says to express your answer in terms of pi, meaning leave the pi there. So I'm going to multiply the 25 times the 7, which gives me 175. Pi will go at the end, and then the units will follow that. In the original picture, I saw centimeters. The units for volume are always cubed. So I have 175 pi centimeters cubed, or you could say cubic centimeters. You can read it out loud either way. If they wanted you to round that answer, you would have to type the pi into the calculator. Just in case you're curious what that answer is, if you're trying it at home, 175 times pi is approximately, put it up here because I'm running out of room, approximately 549.8 cubic centimeters. Now let's take a look at the surface area, SA. I've already jotted down the formula for surface area of a right circular cylinder. We got 2 times the number pi times the radius squared, which we already said is 5 to square, plus 2 times pi times the radius r, 5, times the height, which was the 7. Now number crunching time. We've got to do the exponent first. Bring down the 2 and the pi. 5 squared for 25. Plus, now I can start multiplying. On the right, I got 2 times this 5 over here for 10, times the 7 for 70. Bring down the pi. In front, I got 2 times 25 for 50. Bring over the pi. Bring over the plus 70 pi. I'm running out of room. And you can pretend pi is kind of like x, and that these are like terms. If I have 50 pi and I want to add it to 70 pi, well, if I had 50x in algebra plus 70x, I'd have 120x. So 50 pi plus 70 pi would be 120 pi. The units are squared for any kind of area, including surface area. So this is centimeters square, or you could even just say square centimeters. 120 pi square centimeters is the exact answer in terms of pi. If I type that into the calculator, including using the pi button, and rounded it, this would be approximately 377 square centimeters. Because it's 376.99, and when you round up, 377 that becomes. Let's take a look at one more. This is an easier shape, I think, to deal with because no number pi, since there's no circle. This is a rectangular solid, a box shape. The volume is length times width times height. So we just simply multiply the 3 numbers you see. Honestly, you could do it in any order. So I'm going to say the length is 4 times the width is 3 times the height is the other 3. 4 times 3 for 12 times 3 is 36. Pictures in inches. Volume units are always cubed. So 36 inches cubed. Surface area, 2 times, I'm just going to call 4 inches the length, I'm going to call 3 inches the width, and the other 3 the height. Let me just identify L, W, and H, just to make sure I don't accidentally forget something here. Going back to our surface area formula, the length was 4 times the width W was 3. Bring down the plus symbol. 2 times, again, the length L was 4 times the height H was 3 plus 2 times the width was 3 times the height was also 3. Let's see here. We got 2 times 4 for 8 times 3 is 24. Got to multiply before we add. Good old order of operations. Bring down the plus symbol. Go number crunching. 2 times 4 times 3 for another 24. Plus 2 times 3 is 6 times another 3 is 18. So finally we're going to add 24 plus another 24 plus my 18 gives me 66. We're computing surface area where the units are squared, so that's going to be inches squared this time. So 66 square inches, final answer for surface area for B.